Hello, 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 everyone. This is Dr. Mary Payton with All About STEM Radio. As you know, I come to you every Monday from 7 to 8 p.m. Central Time here on Fishbowl Radio Network. Yes, I'm back in Texas and dealing with the wonderful Texas storm this week or last week. But we're slowly coming out of it. Well, ladies and gentlemen, I say this every week because I am so lucky to have some outstanding guests on my show. And this week is no exception. I have a young man. His name is Jervaughn Hunter. He is a bioengineering PhD student at the University of California, San Diego. And I want him to tell us his story. He's going to find out that we are connected in a way. Well, we know some of the same people. You know, they say 6 degrees of separation. When I told my adopted daughter about him, she goes, "I know him." So this is going to be another great conversation. So, Jervaughn, are you there?
Yeah, I'm here.
Okay. I cannot hear you through my headset, so I don't know what's going on. It may be my headset. I just may be deaf. Can you put that in another socket? Okay. Hello?
Sure. Can you hear me now?
Okay, I can hear you without the headset, so I'm not going to worry about it. No, it may be my headset. I may not.
Everything's going well.
Okay, we're good. All right, so how are you, Jervaughn? I know you're still at work, so because it's early there in California. But can you tell us introduce yourself to our audience.
Sure. Hi, everyone. My name is Jervaughn Hunter. Like Dr. Mary mentioned, I am a third-year PhD student in bioengineering at the University of California, San Diego. Just a little bit more about myself is I'm not a resident of California. I was born in small town, Mississippi. So I was born and raised in Port Gibson, Mississippi, really small town by the Mississippi River. Let's say about 60 miles southwest of Jackson, about 30-ish miles south of Vicksburg. I've traveled a long way to get out here to California to pursue a PhD in bioengineering.
Yeah, that was another thing that caught my eye when I was going over your bio, and I'm like, oh my God, he's from Mississippi. Because my younger son, we had him in Forest County in Mississippi because I was commander of Southern Mississippi back in the day. And I was like, okay, that's one thing that put us together. And then Valine Garberry was the other thing, because when I said your name, she goes, I know him, because she's also a UAB student. She's finishing her doctorate.
She's a prep student.
Huh?
She's a prep student a few years before me.
Yep. So she's doing her dissertation now. She'll defend on March 29th, I think. So I'm excited. I'm totally excited about that. But
oh yeah, I know she's going to do like great things. Like she was amazing when I met her. So I know she's going to do phenomenal.
Hey, I'm excited about all of y'all. So before we get into what you're doing now, I want to kind of talk about your journey. You came from Mississippi, started at UAB. How did you decide where to go to college, and what was your major at UAB?
Okay, so to start, like I say, being in Port Gibson, Mississippi, it was a pretty small, like predominantly African American town, like Alcorn State University and HBCU.
Yep.
It's 15 miles away from my home. Like, it's not far. So growing up there, I'd always been around higher education, seeing people going off to college and such. I was actually fortunate enough to graduate valedictorian of my high school class. Oh. And, high schoolers, we're kids. We have no idea what we want to do. I was in JRTC for a while as well. I ended up being battalion commander around my junior year. And I wanted to actually go to West Point. Like, I went and got Congressman Thompson to nominate me to actually go to West Point. And as you see now, I didn't go that route. Something clicked in my head. I was like, oh, wow, I kind of don't want to go into the Army anymore. I don't want to actually be an officer. I kind of want to go into the sciences and engineering. And what really struck that nerve, because, like, small town Mississippi, like, I had no idea what bioengineering was. Like, engineering, I'm thinking electrical, mechanical, maybe aerospace, but I had no idea there was a such thing as bioengineering. You just don't hear about it in that part of the country. I can't think of any biotech companies anywhere near. So what happened to me was, actually in high school, you take these quizzes and such that say, oh, help me match to my future career, or college and such. So I've done a few of those, and they kept saying, oh, yeah, I think, you're pretty good in math, science, you should be an engineer. So I was like, okay, the test told me I should look into engineering. I'll try engineering. And one day I got a brochure in the mail from UAB, so I've never heard of it. I honestly hadn't looked at any schools other than West Point. I had not looked at any schools outside of Mississippi because I had applied to Mississippi State. And UAB just popped up out of nowhere. I was like, oh, what is the University of Alabama, Birmingham? That sounds so cool. And I'm reading through their list of majors. And, of course, B is at the top of the list alphabetically. So I see this thing called bioengineering. I was like, whoa, what is that? I've never heard of this engineering. What is it? So this is 2011-ish. So I was like, okay, let me run to Google and see what I can find out. I was like, oh, there's prosthetics and things like that. So, like, that's what's in my head the whole time. Like, these are people who manufacture and make prosthetic limbs for people. So, like, that's as far as my mind was at that point in time. I was like, oh, bioengineers, they create prosthetics. I was like, that's interesting.
Okay.
They take engineering concepts to help heal the body, or to help, improve people's lives through engineering. So that kind of stood out to me and made me want to look further into UAB.
Wow. And, when you got to UAB, coming from Mississippi, was there like a shock for you to be on a college campus, or are you like most young people who are around Alcorn? You had been on college campuses, you had done things. So how was it your first year at UAB?
So my first year, like I said, I've been around college campuses before, so it wasn't that much of a shock. The thing that shocked me the most was being at a way more diverse university than I've probably ever seen, like compared to anything I've seen maybe at Mississippi State or even at Alcorn itself, where you maybe have a majority of white or a majority of black. Being at UAB is the first time I ever met anyone of Asian descent, or anyone who's Indian, or anyone from the Middle East. Like, this is my first time ever meeting people like that. So I'm actually meeting people from across the world, as opposed to, like, growing up, I hadn't seen anyone other than black or white people. So that was the biggest shock for me, actually going on to that campus and actually seeing all of these different people. I know I mentioned graduating valedictorian. However, going to college, UAB, those first few classes, especially in engineering, just hit me in the face, because I had no idea what was going on while I was sitting in some of the classes. I remember the first time I sat in General Chemistry 1, and they talked about avocados. See, I'm already messing it up. Avogadro's number.
Avogadro's theory, yeah.
And we just joked, and I just remember sitting up. It's like, what is avocado, and why do we need to know his number? I'm so confused. But yeah, so it's like I'm learning all of these new things and just being shocked by all of this higher learning. So those are the things that, like, kind of just hit me quickly, going from just having to learn a lot very quickly and trying to keep up with peers, and then learning to interact with people from all walks of life. So those are the two things that kind of hit me immediately at UAB.
I mean, I can understand, because, when I was in Mississippi, it was like there wasn't that much of a diverse population. So it was like I had to figure out, okay, because I had been, from Texas and being all over the world, I'm like, oh, I'm in Mississippi. But I loved it. Oh my goodness. I just love going down to Gulfport and Biloxi and all of those places. But while you were at UAB, you weren't just a student. You did some other things while you were there too. And I noticed when I was looking at your bio, you worked with Trio and Nesby, and you even pledged. What Greek did you pledge? Go ahead on, so people will know.
Well, of course, I had to pledge the greatest fraternity, Omega Psi Phi Fraternity Incorporated.
Why do y'all always say Fraternity Incorporated? Because, see, I'm a Delta. We just say Delta Sigma Theta Sorority. We don't go into the incorporation and all that. Why do y'all... No, I'm not going to ask you that. I'm just messing with you.
You got to let them know.
I'm just teasing with you. So, y'all, this is a cue. But being involved in other things other than education, other than what you went... being involved in other things in college other than what your major was, how important was that to your educational career?
It made me learn to, one, accept failure, and two, to just not give up on helping other people. So Trio, I actually didn't even know I was eligible for Trio and such. Like, I talked to my little sister. My little sister, she went to Alcorn State, actually. She went to Alcorn State, and she was doing the Trio program there. And I was like, wait, I didn't know I could do that here. So I ended up seeing their tent at the at one of their days where all the student services and things were out on the green at UAB. Mm-hmm. And I just went up to the Trio programmers and talked to them. I was like, kind of like a junior now, but it is too late to join. I think it was like 2015. This was like, I'm kind of interested in getting that help and being, helping where I can. I was able to apply because, I think it was EFC, estimated family contribution was 0. So like that's more of the students that Trio tends to take, lower income students.
Yeah.
To help us, help us make it through college, help mentor us, help guide us, help give us a family. Like Trio was legitimately a family at UAB. So I really enjoyed joining that group and actually being able to give back because they had these things called peer success coaches, where upper class students actually helped mentor and talk to some of the underclass students. So I've really enjoyed doing that every semester, getting a new group of mentees per se, or peer success coachees, and actually getting to know them, learning where they're from, and actually keeping in touch with a lot of them to this day. So I really enjoyed getting into mentorship. I think Trio really pushed me into mentorship, while joining Omega ended up pushing me into leadership and understanding failure. Like you said, I pledged my sophomore year. So ironically, that sophomore year, I decided I also wanted to take my first ever biomedical engineering class.
Okay.
And I can recall failing that class with a 47 F. So I was like, oh my God. So it just really struck me, like, how do you want to stay in this major? And you have not only failed the first introductory class to the major, but you failed it in the 40s. So that was really a shock to me. But after pledging, after getting actually other like-minded men who kind of helped build me up and talk to me and actually had my back throughout the whole process, it actually made me realize, a failure was not going to stop you. Don't change your major. That's one failure. Take what you get from it, learn from it, and move on. And that's kind of what I did with that. I ended up using the academic forgiveness that UAB offered, and I took the class again and passed it. And, continued to have a few hurdles here and there, but I ended up, of course, graduating from UAB with a degree in biomedical engineering.
Wow. And you know what? You just made me more proud of you than I already am. You stayed in there. You took the academic forgiveness, and you didn't quit. You didn't give up. So, hey, that is huge, huge, huge kudos to you. Um, Now you left UAB, and did you go straight to University of California, San Diego, or did you go somewhere else first? Or
Uh,
when you left, you okay? Let me back this truck up just a second. I got too many questions in my head. Um, did you have to get a master's before you started your PhD program, or is it all inclusive?
so it's not quite all inclusive. Like currently, I could get my master's probably next quarter if I
Uh
wanted
huh.
to, but I don't need to. Like I've just had enough classes for it. So one thing and one misconception that I had when it came to getting a PhD in the STEM field, especially, and this will help answer your question as well. Like it took me about 5 years because I told you I had a bunch of hurdles,
Yeah.
in undergrad. And so instead of finishing in 4 years, I finished in five
Mhm.
and ended up still not knowing what I wanted to do
Okay.
afterwards. And someone told me, like I was talking to other graduate students I met across campus, and even my fraternity advisor, um, Dr. Brian Sims, he ended up telling me that, hey, why not do a PhD? Like, you're a black man in academics. Why not actually push toward for it? It's like how few of us are there. And he really actually saw that in me. And then he also ended up telling me about how actually these STEM PhDs are funded. So it's like you're
Mhm.
not coming out of your pocket to pay for your degree. Like I'm totally funded by university fellowship that first year. And now I'm on a training grant, and then also funded by my faculty advisor. So
Mhm.
you're funded through your through the program. So it's not like having to go forward and get a master's where you have to actually come out of pocket for it.
Yeah.
The PhD is funded. If you don't mind, I'll actually back up one more time because I'm not actually being as linear as I would like to be. To answer your other question, no, I didn't go straight for a master's, but neither did I go straight from a bachelor's.
Okay.
So what that means is, like I was saying, during my last year at UAB, so my last year of undergraduate school at UAB, I ended up seeing this flyer. Ironically, the flyer was to a REU program
Okay.
here at UC San Diego. um, for the listeners that don't know what a REU is a research experience for undergraduates. So mind you, it's January of my last semester of college. So I know that summer, obviously, I will no longer be an undergraduate. But I emailed the professor anyway. I was like, hey, I really want to get research experience, and I understand that this is a program for undergraduates. However, I still wanted to see if there was a way that I could come and actually get research experience because I never had research experience as an undergraduate. So I ended up reaching out to the professor over the program, and he was like, well, of course, no, you can't come do the REU because you have graduated. Um, so I was like, that's fair. It doesn't hurt to try, though. So I wasn't too upset with that answer. But what he did tell me was, ironically, at my own university, which I had no clue at the time, there was a post-bac program has pretty much the same role
Uh
as
huh.
what an REU would be, but for people who have their bachelor's degree.
Hmm. See how
So what
much?
I ended up doing was, oh, sorry.
I was gonna say, see how much you learn when you ask questions.
Oh yeah. You can never be too afraid to ask. The worst thing they can do is tell you no. And if they tell you no, they just told you no. They didn't hurt you. So it's fine.
So,
But I ended up applying to that prep program and
okay.
was fortunate enough to get in. So that's what I did right after my bachelor's degree. I ended up doing this NIH, so National Institute of Health, funded post-baccalaureate research education program for 1 year, so 2017 to 2018. And I was actually able to get my first taste of independent research through that program.
Oh, okay. Now, how was that independent research for you?
It was an eye-opening experience.
In what way?
So one, I was always interested Well, not always. So after I took a biomaterials class in undergraduate,
Yeah.
and during my senior design project, I wanted to take a more materials engineering type of route to solve our problem. Those two experiences actually led me to being interested in doing biomaterials or tissue engineering kind of
Mm-hmm.
research. So what those two would be is using biological materials or cells or cell communication tools, so using different molecules to actually communicate with cells,
Yeah.
and using that to actually treat and heal the body. So that's what I wanted to end up doing, tissue engineering and utilizing biomaterials for tissue engineering, while also treating cardiac conditions. So like anywhere from heart failure due to myocardial infarction, which is a heart attack, or any other form of heart failure. So I ended up joining the Dr. Jay Zhang's lab.
Mm-hmm.
He was currently, at the time that I joined his lab, he was the department chair. So I didn't work with him as hand in hand as I thought, but I was able to, well, as I thought I would be able to. But I actually worked with a professor that was under him in the lab, so one of his assistant professors, Dr. Zhu. And Dr. Zhu actually helped me learn a lot from doing my first little bit of heart tissue culture. So actually, after we harvested the heart from some of the animals that they had done their experiments on, he actually showed me how to take that heart and freeze it so that you could make sections from it, so that you can actually go forth and do histology and actually look to see if it was healing after the treatment was delivered, or even teaching me how to do other forms of staining, et cetera. So all of the different lab techniques he taught me during that time. And I was actually fortunate enough as well to work with induced pluripotent stem cells. And this shocked me even more than anything else that I'd ever seen, because what induced pluripotent stem cells are is they're cells that can be harvested, so somatic cells from your body, which, let's say you take, if I'm not mistaken, maybe a fibroblast, you could probably take it from ear and reprogram it, and you can make it into a heart cell, so a cardiac cell or cardiomyocyte.
Yeah, because I know every cell in your body, roughly, most of the cells in your body, roughly, has all the genetic material to make any body part that you have. But based on where they're located, the different switches are turned on and off to make, fingers, hair follicles, like you say, the structures of the ear, so on and so forth. Some people think, well, the cells in my finger are just cells for the finger. But no, y'all, there are switches that turn off and on within that DNA to make those different structures. Hopefully I'm saying that right.
That's pretty close to accurate. It's like using, well, especially for the pluripotent stem cells that I was mentioning, and I did not study how they induced them. They only gave them to me after they induced them. But yeah, you actually go through a few different pathways. So you just end up delivering specific molecules or such that inhibit a pathway, and it'll allow the cell to go down a different lineage. So what happened was, once these cells were differentiated, they became, so differentiated means they turned into another type of cell. Once they became the cardiomyocytes, I was able to actually work with them and culture them, and these cells would beat. So the way your heart beats, these cells would actually beat on a tissue culture plate. And that's what really surprised me, because I had never seen that before. And I was like, this is really cool. So the idea of that lab at that time was to utilize these cells to actually implant them back into the failing heart. The heart that was failing due to heart attack. So you actually have these beating cells that we can grow in the lab and want to deliver them back. So I thought that was really cool.
Now you keep talking about lab work, doing this in the lab and that in the lab. A lot of going back into, when we talk about being in a STEM field, when we talk about being in an engineering field, being able to work in a laboratory and actually, work on these various projects or things that you work on, how does that make you feel? Because a lot of people, oh, well, I'm a mechanical engineer and I build parts, or, it's different working in a lab than it is doing a lot of the other things that we do.
There are days when I love it, and there are days when I'm like, oh, wow. Because like I said, in earlier, you just have to learn to live with failure and learn from what you failed at. Just try not to make the same mistake twice. If you do make a mistake, learn from it. So some days it can get like that. It's like, oh my God, I made this mistake. That might set me back a day, or it might set me back a week. Other days I can get overjoyed because it's like, oh my God, this experiment finally worked. And I actually have like data I can look at and like move on to something else, or actually be able to definitively answer this question based on the data. So I think that's, in a nutshell, I do enjoy being in the lab more than I don't enjoy it. So I don't mind being here. It's actually very peaceful at times.
And I liked how you put that. Sometimes things don't go exactly as you plan it, and that was when I was teaching. Now I'm supposed to be retired. We're going to see how long this is going to last. And I used to have my students do something. If it didn't turn out just right, they would, change their hypothesis. They'd want, oh, can I get a new paper because I want to say that this is actually what happened. And they never understood that not succeeding 100% is part of the situation. When you do labs, everything isn't 100%. And then when you get it right, they would get excited, I would get excited. And so I like the way you put that. But I want to go back into your work with cardiac tissue. Mm-hmm. How long have you been working on this project?
Gotcha. So the project that I mentioned from prep,
yes,
was only 1 year. So okay. Right before I was applying to the PhD programs while I was in prep, because that was another condition of the prep program, because it was also to prepare us to go to graduate school. So we were required to apply to PhD programs. So that project with the stem cells was only a year. But ironically, the work I'm doing now, it doesn't use stem cells per se, but we use a cardiac-based material. So what we do is we use hydrogels, and these are polymer structures that swell up with water, and they're fascinating constructs. Like the way we make our hydrogels is we actually make these gels from porcine tissue. So we take pig hearts and we can decellularize them, so remove all of the cellular content and leave nothing but the extracellular matrix, so the proteins that make up the scaffolding. So most people think of your body as just cells. No, there's actually a polymer network called the extracellular matrix throughout your body. So if you stripped away all the cells out of someone's body, they'll still be there in a polymer construct husk. So that was something also that fascinated me, because I remember even being a kid, I was like, yeah, the body's made up of cells. And I was like, I had no idea that, the cells have to connect to something, right? So that was interesting in itself. So coming from not knowing about the extracellular matrix and now utilizing it to treat different forms of heart failure was pretty cool. So just to talk about the material a little more to help kind of visualize it, if you think about getting rid of these cells, we actually wash the cells out of the tissue. So the way you would wash clothes or something, we take a detergent, not quite Tide or anything, but we do take a strong detergent, and we completely wash the cells away to leave the extracellular matrix behind. And once it is left behind, we'll take it, excuse me, and we will freeze dry it. So you want to just have a nice crisp structure. Just remove all the water from it. That way we can mill it down or grind it down into a fine powder. So the fine powder that we make from this substance is reminiscent to if you go to the grocery store, right, and you get a Jell-O packet to make Jell-O. So the same thing that Jell-O is, like the powdered form. That's what you can think of this material. So you know how you add hot water or such to that Jell-O powder to make Jell-O. Our material, after we break it down or grind it down into a powder, we use an enzyme solution to break it up a little bit more. Break up those polymer chunks inside such that they will want to self-assemble again when in the right conditions. So if you were to inject this solution after it's neutralized to a neutral pH, if you inject this material into the body, it will form a gel. It will form a gel at body temperature, so around 37 degrees C. And it will also form a gel when it comes in contact with biological tissue. Also at the same temperature that I mentioned.
Wow. I mean, I remember when I spoke with you at the STEM Success Conference, I'm sitting there and I'm listening to you, and I was like utterly and totally fascinated because I'm sitting in my classroom because I was still teaching then, y'all, because it's only been a few months ago. And you started talking about this, and you remember we had to ask for extra time because I was like just totally and utterly interested in this research. And that's one of the things that a lot of our young people don't know and don't understand is that, you know, you can go into STEM fields to where as you do research, such as what you're doing, and, you know, it's just amazing because let's think of what's going on right now with COVID-19. You had to have somebody in a lab doing research, trying to determine what this situation was, and you know, other research still has to go on, like you're talking about working with cardiac tissue, and so on and so forth. Now you've done these researches, you've worked on these projects. Have you been able to do any presentations or presenting of anything that you've done in your field?
Yeah, so actually when I started, so our material that I was just mentioning,
yes,
it's derived from the left ventricle, so the main pumping chamber of the heart. And it is already through my advisor, my PIs, through her work, has actually gone forth into clinical trials. So the left ventricle material has actually gone forth to be in a safety study within people. So when I got here, I just wanted to ask her, you know, if we're using left ventricle material to treat, you know, heart failure in the left heart, so after a heart attack, why have we not looked at using a right ventricular material to treat like right ventricle heart disease? So she's like, oh, okay, that's pretty interesting. And she told me that I could go ahead and begin making this material myself. Well, fast forward about maybe 6 or 7 months after that, I was able to characterize this right ventricle-based material. So characterize it just means I was looking at what its composition and its makeup was, kind of comparing it to that left ventricle material, looking at its mechanical properties, so just looking at its stiffness and such, or does it exhibit the same mechanical properties as the left ventricle material. And then I was able to present this poster about these findings, just comparing those two materials at the Biomedical Engineering Society conference that was in Philadelphia. It's 2019. Yeah, so yeah, right before the pandemic. So October of 2019.
Wow. So with the research that you did on the right ventricle material, did you find that there were many differences or similarities?
So composition-wise, yes, they're pretty identical when it comes to makeup. So just protein distribution. Okay. Mechanical properties look similar as well, but I'm currently still doing more cell studies, so actually seeing how cells react to each of the materials to see if there are any differences there. So while I didn't see too much, while I can't say definitively if I saw any differences in the mechanical or compositional properties, I still wanted to see how it works as a biologic.
Okay. All right.
Mm-hmm.
This is amazing. I could just imagine what your day looks like working in the lab and doing this work, and then being able to work on an issue or a problem. Well, not so much a problem, but on a project that you thought about on your own. Now, how much longer do you have before you finish the program?
So everyone does an average of about 5 years. So I'm in year 3 now.
You've been there. Did you say you've been there 3 months?
3 years.
Okay. Okay.
So I'm in year 3.
Okay, that's what I thought. All right, so you've got about 5 years to go?
About 2 more.
2 more?
On average. Mm-hmm.
That's amazing. Because I won't even tell you how long it took me to finish my doctorate, and I was in the middle of a war and all this other kind of stuff. But anyway, so when you finish...
I'm hoping for 2 years.
So when you finish, what do you think you're going to want to... Have you thought about what you're going to want to focus your efforts on? What are you thinking about doing?
So I'm definitely interested in translational medicine, and that's taking therapeutics from bench, so in the lab, to bedside, so getting it into clinical trials and then out into the market to actually help people. That's one of my major goals.
Okay, wait. Before you go any Before you go any further, what is transitional medicine?
So translational medicine translational medicine is literally just, in a nutshell, translating your findings from preclinical studies, so in animal models, into the clinic, so actually using it in people. So getting your therapeutics and such through the preclinical studies that they need to go through to be approved in clinical studies.
Okay. All right.
Mm-hmm.
So now what were you saying you were looking at trying to do with this transitional medicine? Because
just sticking with the, sticking with that heart failure motif for right now, just looking to use biomaterials to actually treat the failing heart, to actually give people a few more years, on their life, because the right ventricular heart failure is no laughing matter. And it's one of those silent and more understudied heart failures, because everyone hears about a heart attack. They're like, oh yeah, they had a heart attack here and there, but you don't think about the right ventricle as much, and people do die from right ventricular heart failure. So I want to actually go into that, helping that patient population.
That's interesting. I'm just amazed about this work. And, I know along the way, you've talked about some of the people that you've worked with and some of your mentors, because, and I tell people all the time, a lot of things I do, I can't do alone. I can't do by myself. I got a great producer here. Who's my producer today? Trevor. I've had Trevor a couple of times. But, can you, give a shout out or a heads up or a hands up or something to some of the people that have mentored you or supported you, and kind of tell my young audience especially how important that is?
Mentorship is extremely important. I know they heard the whole adage, it's not what you know, it's who you know. And I can subscribe to that a little bit as well. Like, knowing these people can push you further into things that you would never have thought you needed to know. So having mentors is just one, like you mentioned, it's just one of those things that you can't really live without, especially if you want to be highly successful. I have actually mentors at several different levels. Like I mentioned, my fraternity advisor, Dr. Sims, he's a mentor of mine, as well as like even so a peer, so someone else who's in graduate school currently. One of my line brothers, he's Lavarius Harris, LV. He's a great mentor of mine. I talk to him about everything from moving Black men forward to just talking about what we can do to push each other or, help lift as we climb. Excuse me. Or even and just talking about life, just moving forward. Like, we both enjoy giving back, so I always hit him up like, hey, what are you thinking about today? Or, what kind of moves can we do to actually bring more people with us? Like, I'm a huge advocate for getting more Black children into STEM because, like I said, had it not been for a random brochure from UAB one day, I probably would not have thought of bioengineering or biomedical engineering. And I definitely had no one to tell me about it at the time. So I want to actually go and do that with other students and actually bring them into various different STEM fields. Just because, one, they are able and we are able. You don't have to think that you just have to be phenomenal in your grades to do it either. Like, you should strive to get good grades, but it doesn't hurt, again, to slip up here and there if you can learn learn from those mistakes and learn from those failures.
And those comments are amazing and enlightening because, a lot of our students, that's why I was so excited to have you on. A lot of our students don't know what, these various engineering fields are, and they cannot see themselves in them. And they don't, and when they hear about it, they don't know what they are and what they do, what they're for, how can they make a difference. And to be able to see someone in that field, although they can't see you, they can only see me because I'm on Facebook Live, but to hear from you and I'm going to go back to your undergraduate for just a second, to hear the fact of the matter that you didn't spend all of your undergraduate and probably now your graduate years just with your head in a book. You had you had a life outside of education that made you well-rounded. And
definitely. I can't stress work-life balance enough. Like, I love to go hiking. I love to go out. I'll have a drink here and there. Like, I enjoy doing stuff. I like video games. I like hanging out with people. So, like, you have to have a really good balance. I like doing community service and such. So, like, you definitely have to have a really good balance.
Mm-hmm. Well, Jervaughn, I have enjoyed. I mean, can you not believe we've got Trevor sitting here holding his fingers up at me and looking at me? We've got 2 minutes left, but I want to thank you so much for accepting my invitation to come on the show. I am so glad that I met you at the STEM Success Conference, which was only the second conference. I went to the first one, I went to the second one, and I will definitely be at the third one. And so, hey, if you ever want to come back, because we've got to hear from you again, because I've still got questions that I didn't ask. But we only had an hour. So thank you for coming on, and you have an open invitation to come back when you, especially, I'm going to love to call you Dr. Hunter. That's going to be great.
Thanks. I'm looking forward to it. I really enjoyed talking with you today, too. And, even talking to, hoping some of the younger students can hear me. Like, if a little country boy from Mississippi can do it, like, I promise you guys can do it.
All right. Thank you so much.